So in this problem, we're supposed to go to benzene to some sort of amide, right? And we're asked how we can do this reaction here, and it requires a little bit of understanding of not only aromatic chemistry, but also, what's it called? Carboxylic acid derivative chemistry. So we can use any reagents we want. How do we do it? Okay, so I notice our benzene here, and we notice in the product we have a nitrogen directly off of that benzene ring. That clues us in a little bit. We need to add a nitrogen directly on the benzene here, right? So no matter how we react it, the benzene has to react with some sort of nitrogen to get on there, all right? Unless we do some sort of weird organometallic chemistry, but that's not the scope of this course. Okay, so we have a benzene ring, and I know that I can add a nitrogen if I use nitric acid and H2SO4. That's nitration of a benzene. So HNO3, all right, that's nitric acid, and then we're gonna use H2SO4, right? What that's gonna do is that's gonna make that NO2 ion, and then it will just attach itself right here, right? Go through that sigma complex. So we have our NO2 group. Alrighty, now here is the key part, and you can't really see it unless you do a retrosynthesis, okay? So let's actually do that. So this is the forward synthesis. Let's do a little bit of retro now, so the retro. Okay, so we end with this nice little benzene amide. Okay, and we're asked, how can we make that? Well, I know that using a little bit of carboxylic acid chemistry, if I had ethanoyl chloride, right? So like this, and then Cl, right? If I have ethanoyl chloride, I could bring in this group here, aniline. If I bring in aniline, and let's say I do it under acidic conditions, H2SO4, right? I add a little bit of acid there to kick that reaction off. Well, I know what's going to happen is, well, I'm going to get this, right, if I react it with ethanoyl chloride. Okay, so a pretty elementary reaction. We know we'll make that. Okay, and now this is where we see some convergence, okay, convergence of the retro and the normal synthesis, right? We're going one way, right, we have an NO2, but we need aniline, okay? If we could turn this into aniline, we could do this reaction here and make our product. Okay, so that's exactly what we want to do. But how do we get to this step? Well, in your undergrad course, you're never shown a mechanism for this, but you are told that if you use iron or zinc, I'll use iron, and HCl, hydrochloric acid, in step 1, you're going to get a protonated NH3 group there instead, right? It goes to that very long mechanism that your professor probably did not have you on the hook for. In step 2, we're going to bring that NH3 down to NH2 by NaOH, right? Adding just the right amount to make, let's say, the pH equal the pKa. So we're going to get this compound here. NH2, that's aniline, that's exactly what we need, okay? So you can see that the whole synthesis is done. We're going to start with benzene. We're going to do a nitration of it. We're going to get NO2. Then we're going to reduce it down to NH2, aniline. Okay, and then we're going to react it with ethanoyl chloride and acid, and we're going to get our product. So that's the overall reaction there. I hope you enjoyed this video. If you did, please like, subscribe. Anything to support would be greatly appreciated, and I hope you have a wonderful day.